Welcome back to another video tutorial in our Android Native Development Starter course. So in this video, we're going to be going over a couple more types of operators, our comparison operators, our logical operators, and then finally we're going to get into one of our logical structures, something called an if statement. And before we get into any of that, I'll just briefly touch on a Boolean data type. So if you remember in the previous videos, we went over a bunch of numerical data types and then also a bunch of text data types. And I briefly mentioned something called a Boolean data type. So we're going to be using a Boolean data type quite a bit when we deal with logic and logical flows and comparisons, because a Boolean data type is a data type that can hold either one of two values. It can be true or it can be false. And you'll see in my code here, I've got 6 integer data types up top, or 6 integer variables up top, x, y, and z, which is 3, 7, and 2, respectively, and then a, b, and c, which are 1, 2, and 3, respectively. And then down below that, I have my comparison operator section, and I've got a variable called x equals a, and you can see that's of type Boolean. Y does not equal 7, again, that's of type Boolean. X greater than y, so that's of type Boolean as well. All of these in this whole section are going to be of type Boolean, and that's because our comparison operators are always going to be returning either a true or a false value. In other words, they're always going to be returning a Boolean data type. So here I have x equals a is my variable name, and I'm using my assignment operator to set that equal to this expression here. And that expression is x equals a. So whenever you see a single equal sign in Kotlin, that's going to be your assignment operator. And whenever you see a double equal sign in Kotlin and Java and C and a bunch of other languages as well, your double equal sign is going to be your comparison operator. So in this case, this expression here, x equals a, or the value of x is equal to the value of a. Well, here, x is 3 and a is 1. So this is equivalent to saying 3 is equal to the value of 1. And that is, of course, not true. So this will return a false. And you can see over in our log, x equals a is in fact false. And then moving on, y does not equal 7. So for the equals operator, the equal to comparison operator, you use the double equal sign. For the not equal to comparison operator, you're going to use an exclamation mark and then the equal sign. So y does not equal 7. So y up here, actually, you can see I set the value of y to be 7. So this expression, y does not equal 7, because y actually does equal 7, that's equivalent to asking 7 does not equal 7, and that's, of course, nonsense. That's false, because 7 does equal 7. So here, y does not equal 7. It does, in fact, come out to false. And then down here, you have your greater than and your less than operators, and these should be fairly familiar to you just from math class. So x greater than y, that's a variable that I'm going to set equal to this expression. X is greater than y, and x is 3, y is 7. So this is the same as asking if 3 is greater than 7, and 3 is in fact not greater than 7. So that also is going to return false. And then below that, we're going to check the opposite of that. So is x less than y, and 3 is in fact less than 7. So x less than y is going to evaluate to true. Then you have z greater than or equal to 8, or to b rather. And our z is 2, and our b is also 2. So this sign right here, you have your greater than and then an equal sign. So in Kotlin and most programming languages, this is your greater than or equal to operator, which is going to be your greater than sign followed by an equal sign. And then the same thing for the less than or equal. It's going to be the less than sign followed by an equal sign. So z is greater than or equal to b. Well, z is 2 and b is 2. So it's not greater than, but it is equal to. So this is going to evaluate to true. and it does. And then C is less than or equal to Y. So C is going to be 3, and Y is 7. So C3 is in fact less than 7, so that's going to come out to true. Now, after our comparison operators, we have something we should talk about called our logical operators. So again, here, I've got 3 different expressions, or 3 different variables, Boolean variables, and I'm doing some logical evaluation using my comparison operators that we just covered in this section above, and then using some of the variables that we set up before. So x is less than y, and if my x is 3 and my y is 7, that is of course true. And then this right here, where you have these 2 vertical lines, this is going to be your OR sign, your logical operator OR. So what this means is this is essentially breaking our expression up into different parts. So here's my first part. X is less than y, and that we said is true. So what we are really doing here, expression 1 equals true, or, and then x is greater than 10. So x is 3, and 3 is not greater than 10, so this is going to be false. So we've got our 2 statements here, x less than y, and then x greater than 10, and we're doing a logical OR on those 2 statements. And the first one is true, and the second one is false. So true or false is always going to be true, because if you have an OR operator, all you really need is one single expression within that to be true, and the entire thing is going to be true. So Kotlin is actually going to also do something called lazy evaluation. So it's going to come in here and it's going to see x less than y, and then it's going to see the OR. And because it's already evaluated x less than y, and that's true, and we're doing an OR sign, we actually don't care what that is. We don't care about the second half of it because we know it's going to be true regardless of if the second half is true or false. So that's just something Kotlin will do to save some time. And then also, you could see I have an expression here, but I can also just, because I have x less than y saved in a variable here, x less than y, it would actually do the same thing if I just use that variable instead. And at least functionally, that would do the same thing. It would actually be a little more efficient because I've already calculated the value of x less than y. So that would save me a little time doing that. So here, I can put an expression, or I can put numbers, right? I can have 3 less than 7. I can hard code in numbers, but you wouldn't really want to do that because hard coding in numbers, that's never going to change. 3 is always going to be less than 7. But regardless, moving on, after your OR operator, which is again those 2 vertical bars, and that's if you hold shift, those vertical bars are going to be right above your enter key on the keyboard. And then moving on to the second expression, we've got x is greater than y and x is less than 10. So x is 3 and y is 7. So this is the equivalent of asking expression 2 equals x is greater than y. Well, that's false. And x is less than 10. Well, x is less than 10, so that's true. But really, at this point, because we have false anded with something, that false is always going to make an and statement false. Because for and, you need them all to be true for it to be true. If you have even one expression within that that's going to be false, that's going to negate your entire statement. So again, that's just Kotlin's going to do that lazy evaluation thing, which means as soon as it sees a false and then the and sign, it's going to ignore the rest of it and it's just going to write that expression 2 variable to false. Now you have one more logical operator to talk about, and that is going to be your not. So the not operator is just simply your exclamation mark. So if we have exclamation mark and then x greater than y, and exclamation mark x equals a. So this is going to be the equivalent of expression 3 equals not, so x greater than y is of course a variable that we evaluated up here, and x greater than y evaluated false. So you have not false ANDed with x equals a, and x is 2, and a, what is x, 3? Yeah, x is 3, and then a is 1, so x does not equal 3. So this is going to be ANDed with another not false. So a not false is the same as saying true. Because you're negating the false, you negate it to true. So we have true and true. So this expression actually, not x greater than y and not x equals a, that is going to evaluate to true. And it does there. So moving on, we have something in most programming languages, and definitely in Kotlin too, something called an if statement. And what an if statement is I have the keyword if, and then within the parentheses after that, I can put any expression I want. So here I just have true. But really, this is just any expression that evaluates to a Boolean value, which is true or false. So I can have, I can put expression 2 in there. So if expression 2 evaluates to false, so expression 2 is false and true, which it does in fact evaluate to false. So if it evaluates to false, all of this code within the yellow brackets we're going to skip. If it does evaluate to true, all of this code within the yellow brackets we're going to run. So this is basically your most basic version of that, where you have the if, but you also have your if else. So if this expression is true, we run the code within these yellow brackets. Else, meaning if that expression was false, we're going to go ahead and run the code within these yellow brackets. Then we also have your if, else if, else if, else statements, because sometimes you have more than just two possibilities, right? So if this is true, then run this. Else, if it's false, run this. Now, you might want to know, like there might be cases when you want to distinguish more than just between two different cases, right? So like if you're between 100 and 90%, that's an A. If you're between 80, or if you're between 90% and 80%, that's a B. If you're between 80% and 70%, that's a C, and so on. So there's cases where you want to distinguish not just between two possibilities, but between multiple possibilities. So here, for example, if x is greater than y, then we're going to run this code. Else, if x equals y, then we're going to run this code. Or else, for everything else, which in this case happens to be is x is less than y, then we're going to run all the code within these two yellow brackets. So this final else is just a catch-all, meaning if I haven't fallen into one of the conditions in the other if or else if statements within this structure, then we're going to run this code. And finally, one more thing to mention about if statements. Now, if you're familiar with Java or C or C++ or any other coding languages, they work a little bit differently in Kotlin. And what I mean by that is an if statement is actually going to return a value. So for example, here I have this variable message, which you can see is going to be inferred to a type string. And I'm saying if x is greater than y, then here's a value. And this is really shorthand for saying return x is greater than y, but in Kotlin, in an if statement, you don't need the return. So if x is greater than y, then message is going to be set equal to this string. Else, if x equals y, then message is going to be set equal to that string. Else, if x is less than y, then message is going to be set equal to that string. So you can see here I'm logging that, and we're getting x is less than y. And the reason we're getting that is, of course, it's going to come into our if statement. It's going to check this variable, which is false. It's going to check if x equals y, which is also false. So it's going to fall into the third category, which is our catch-all else, which will return x is less than y and store that in the value of our message variable. Now, one more thing to mention down here. This statement inside of your, this expression inside of your if statement, you can have that be as long and as complex as you want. So for example, here I have if and then parentheses, number greater than 10 and number not equal to 17 and x is greater than y and x is not equal to 8. And then all of that expression ORed with x equals 8. So you can have really complex expressions within an if statement. It's good practice not to, however, because if I write this code and then I come back to it tomorrow or the next day or 6 months from now, and I'm trying to figure out what actually I'm trying to check for in this if statement, well, if I run across a big long expression like this, that's going to be quite confusing. So it would be much easier just to make a value, make a variable. So for example, here we could say val student pass the test, and then set that equal to this big long expression. And I guess that doesn't really make sense for that name. But now, if I'm coming back here later, and I have no idea what that expression means, but I get here and I say, if student passed the test, well, I don't have to know what that expression means because the name of my variable tells me exactly what I'm trying to do with that expression. So it's just good practice to, especially for longer, more complicated expressions, give it an English name that is going to make sense for the next time you come back to it, or even worse, the next time somebody else comes back to it. It's just going to help them be able to read your code much easier, and you won't need nearly as many comments within your code. So that's really all we have for this video here, covering if statements and then logical operators and comparison operators. Hopefully this video is helpful for you. Like and subscribe to our channel if it is, and we will see you all in the next video.